Hello everyone and welcome. Today we will be discussing the master or the layout sketch approach of modeling. And we will touch on two types of the layout sketch. The full sketch, where we define the sketch geometry that will be used to create new features and the model itself, and the control sketch, where we will be defining just the references and dimensions for our model. And we will be designing today this film cassette. First things first, we will be using the Realthunders FreeCAD Link Branch today, because it facilitates this master sketch or the layout sketch approach. And I'll show you why. I will leave the link to Realthunders GitHub in the description below. What you need to know about this version of FreeCAD is that it started as an assembly workbench first, it's called Assembly 3. And then it evolved in a full-fledged branch with additional functionality that improves on stock FreeCAD. While Realthunder designed his Assembly 3 workbench, he acknowledged that topological naming problem is real, and for his workbench to work properly, he needed a solution. So he proposed one. And now, in FreeCAD version 1.0, Realthunder's solution for topological naming problem is also implemented. So this version of FreeCAD is the source for the fix for FreeCAD's biggest problem. Okay, but enough with that, let's start new project. Let's close this one and we will start a new file. We will save it on desktop and call it film cassette. Now, in previous videos we started with the part design workbench. Today we will do it differently because we will use the layout sketch approach. So first we'll start in Sketcher and we will create two sketches. Let's create the first one from the top or XY plane, click OK, close it for a minute and create one more. Now from the XZ plane or the front plane, click OK. Now let's rename them. The first one will be layout sketch top and the second one will be control sketch front. And save the project, hit F5 to update all the views, and let's start with the layout sketch. Edit sketch. Our cassette is round, so let's start with the circle. We will need 4 circles, 2 for the inside axle and 2 for the outside shell of the cassette. Now let's dimension them. So let's dimension the axle for 10 millimeters. Let's zoom in a bit and let's offset the inside circle for 1 millimeter. Now the first outside shell circle will be 21 millimeters in diameter. And the second one will be 25 millimeters. Let's position those dimensions so they're clearly visible. Base sketch is ready, now let's start with additional features. I will start with the central winder tab. Let's zoom in a bit and let's convert the insidemost circle to the construction geometry. Then I will create 2 central arcs. And I will constrain them so they are symmetrical. Let's make these arc points horizontal and these arc points horizontal as well. Now the only thing left to do is to make these 2 points symmetric to the origin. And now you will see that those arcs are symmetric. Now let's add some vertical lines and dimension the distance to be 2 millimeters. Now we can convert our construction geometry back to the solid geometry. Now you will notice that these 2 lines overlap, but this won't be a problem because FreeCAD Link Branch has a solution for this as well. So now let's move on to the film exit. For that we will need 2 lines and create a triangular shape. Let's make it horizontal and start constraining it. So firstly I want this dimension to be 3 millimeters, this dimension to be 6 millimeters, and then we'll need an exit for the film itself. So 2 additional vertical lines are necessary. Let's constrain these 2 points horizontally. And let's dimension the distance between these 2 lines to be 0.4 millimeters. Now we have our sketch fully constrained. And in other CAD systems, the layout sketch can be used this way. just selecting areas that are necessary for feature creation. However, in FreeCAD Link Branch, it's better to clean up the sketch a bit. So let's do that. We can use the Trim Edge tool and remove edges that we won't be using. Now we will see that there are 2 degrees of freedom. Let's test it out. So the first degree of freedom is that this line is no longer horizontal. Let's make it horizontal. And that it's not constrained to anything. So let's make these 2 points horizontal. So now we are back to be fully constrained. And our layout sketch from the top for our cassette body is finished. Click close, save it. We will have a bit different approach in the control sketch. Let's start with it. First, let's project these 2 outside circles. They will be projected as straight lines. What we need are these 2 points, so we know where the shell is. Let's get back to the front view. First of all, I would like to define the height of our cassette. So I will create new line. I'll make it construction line. I will make it symmetrical to the origin. So select the endpoints and the center of the symmetry. Click symmetrical constraint. And let's assign it to be 43 millimeters. Now we will be defining the control sketch for the top and the bottom covers of the cassette. So first, let's create a new line that will define the thickness of the wall. So for that, we will constrain the first point vertically to the outside wall and the second point to the inside wall. This line should be positioned in line with the cassette height. So let's select these 2 points and make them horizontal. I would like to have a smooth arc between these 2 points, so let's create it. I think that this arc is too deep, so let's define the distance. And it will be 1 millimeter. Now we can select these 2 points and make them coincident. Now on the top of the cassette, the axle is a bit protruding. Let's define the distance for that as well. We will create new line and dimension it for 3 millimeters. So this will be the outside wall of our top and bottom cover of the cassette. This will be the extension of the axle on the top side. Now we need to define the thickness of our cover. Let's create a new line. And let's define it as 1 millimeter as well. So this will be the thickness of our cover. And then the inside spool in the cassette has a ring around it that holds the film inside. The thickness of that ring will be 0.7 millimeters. So let's define that as well with additional line. 0.7 millimeters. So now you can see how different the control sketch is from the layout sketch. We are just defining reference geometry that we will use to create new sketches. Let's close it, save the project, and now let's start creating our geometry. Let's go to the part design. We need to create new body as we didn't have it. Let's create a second body as well. It's a good practice to name your bodies, so let's do that. Cassette and the spool. Now let's select cassette and toggle it as active body, so we are working with it, and create new sketch from the top plane or XY plane. Click OK. The first difference between FreeCAD and Link Branch is that you can project external geometry directly into Sketch. You don't need to create the subshape binder first. Let's do that. But you will notice that it will create the subshape binder automatically. It's still in use, but it's automated and it helps with a bit faster workflow. Now we have projected our external geometry. In the official FreeCAD version, you would need to go to the arc and trace the geometry. We won't be doing that. That takes too much time. Instead, let's delete everything. Let's have a closer look to the external geometry tool. We will notice that there is a drop-down. And that's the feature why we're using FreeCAD Link Branch, because we can use the defining geometry. So now what we need to do is just click through our geometry, hit close, select our sketch, and hit pad. So our defining geometry will work and we will be able to pad it. So now we need to understand how far should we pad it. Let's go to the control sketch, edit sketch. And let's see, so the height of our cassette was defined by this point for 43 millimeters. Hit close, get back to cassette. Let's select this point and create the datum plane. Click OK. Now we can get back to the pad, click Edit Pad, and instead of dimension, let's select up to face and the newly created datum plane. Click OK. Let's hide the datum plane and let's mirror our pad on the base XY plane. Click OK. And here's our cassette. Now let's make the cover. For that we will create new sketch. On the front plane, XZ plane, click OK. Hide the body. Let's zoom in a bit. So let's hide our sketches and show our subshape binder. We will work with that. Let's select the defining geometry projection tool and project these two edges. Now we have a problem, we don't see the geometry. To work around that, we can point our cursor where the geometry should be and hit G 2 times, so GG. And now we will see that we have a selection tool. We will see that we are using our subshape binder, here's its name, and there's an edge. Let's select it. And we have projected it. Now the only thing that's left to do is to add our defining geometry. So this vertical line is the thickness, so it's equal to this line. Now we will create second line that is equal to this line and the arc. So let's create the arc and we are fully defined. Hit close, let's show our body, select the sketch and use the revolve tool. Click OK. And our top cover is almost done. Now for visual appeal, I would like this cover to protrude a bit. So what I will do is go to the first pad, select Edit Pad, and offset the face for 0.5 millimeters. And in different directions, so minus 0.5 millimeters. Click Close, and this will give us a nice protrusion here. Now let's go to the top view, create new sketch, XY plane, click OK. Hide our body and show our layout sketch subshape binder. We will use again defining geometry projection tool. Select the axle circle, close, show the body, pocket, through all, symmetric to plane. Click OK. And the last feature that we need is to mirror this cover to the other side. So the revolution and the pocket should be mirrored against the base XY plane. Click OK. And we are done with the cassette body. Let's hide our subshape binders and check our cassette. Now we can just hide the body and select the spool and toggle the active body. Now with the spool we will have a bit different approach. We will start by creating the subshape binder for our control sketch. And we will start by creating some datum planes. So first we know that this point is the length of the cassette and the spool. So let's make the datum plane here. Click OK. The second one is the extension for that spool on top. Let's create one more datum plane. Click OK. And we know where the ring and its thickness is located. So the ring starts at this point, datum plane, and ends at this point, datum plane. OK. Now we are ready to create our spool. So first, let's create new sketch. Select the top plane, XY plane, click OK. Hide our datum planes for now and enable the layout sketch. Select the projection of the defining geometry for the axle. Hit close. Hide the layout sketch because we will be working with the subshape binder. And now we can just pad it, select the appropriate datum plane, up to face, datum plane. Click OK. Now I would like to create the ring around it, so let's hide our pad. Select the datum plane on which we will start the ring sketch and create new sketch. Hide both datum planes. Show us the layout sketch. This time we will project the external geometry as construction because it's not a full circle, it's an arc. And then we will just create new circle that is equal in diameter with the arc. Hit close. Enable the datum plane that represents the thickness of the ring. Enable the body. Hit pad. up to face, and select the datum plane. Hit OK. Let's hide the datum plane. Now, as there's no topological issue in Link Branch, let's select our top face, create new sketch directly on it, hide our body, and project the defining geometry for the inside of the axle. Hit close, let's pocket it, and 5 mm works for me. Click OK. Select newly created inside face, create new sketch, again hide the body, and let's project defining geometry for the spinning tab. Here you can see again that we cannot select the small portion of the circle. We will once again use the GG shortcut and check out which edge we need. It's this one. Let's select it, GG, and the second edge. Hit close, pad, up to face, select top face, and let's offset it by 1.5 mm. Click OK. Now we can select all our features and mirror them on the base XY plane. Let's enable the cassette and check out current results. Okay, this looks good. Now the top side has an extension. In other CAD softwares like Fusion or Alibre or Onshape, you have the functionality to select the face, and it's usually called Offset Face tool. What it allows us to do is to select the face and extend it to the necessary dimension. FreeCAD does not have such tools, so we will need to just extend them by using sketches. Let's hide our cassette, select our top face, and create new sketch. Let's hide the binder so they don't interfere, and let's toggle defining geometry and select these two edges, one and second one. Close. Now let's find the datum plane that shows the extension, this one. Select the sketch and pad up to face datum plane. Hit OK. Hide the datum plane. Take the rotational tab, create new sketch, project defining geometry, 1, 2, GG, edge, 37, GG, edge. Hit close. Now we can once again pad it, up to face, and offset it by 1.5 mm. Hit OK. And let's enable our cassette and toggle active body. So here we go. Now just for the short demonstration, we can go to our control sketch, edit it, and let's say that we want our spool to have 5 mm and it to be, let's make it chubby, 30 mm in height. Click close and you will see that everything updates successfully. Now I would love to hear if you are already using layout or control sketch approaches in your modeling workflow. Leave us a comment below. If you like this video, don't forget to push the thumbs up button and subscribe. See you in the next video.